Okay, super. So I would like to discuss how you can use constexpr on the non-type template parameter, so-called NTTP, to get some HTTP requests for RESTful web services, actually. So I will go about what is REST and so on, but I think most people know. I don't know. Any one of you did watch my CPP talk this year,
No,
or already, or and nobody of you seen that one?
no.
I haven't.
Okay, so it's good because I recycle some of the stuff and so okay, cool. Otherwise I would have another branch, but it's perfect. So we are TP, two people. We're founded the company. We are a small team of four, and we have like a background in C++. I've been working for on Boost Fusion libraries, contributing to Qt on Android as well, and speaking at CPCon, CPCast. And my co-founder is Damien Buhl.
We lost you.
I try to find the best place, but next time I come in Lugano, definitely. Uh, but this year, everything was crazy at TP. All our deadlines were the 24th. Like, we had like so many stuff the 24th of March. I don't know why. I think it's the end of the quarter, but crazy, crazy day today.
Yeah.
So what I would like to discuss in this presentation is the first part here, is because I don't think we'll have the time for the other one, but that could be for another meetup. So what is REST and how to write REST in C++ and before all how to write modern REST or modern C++ 20 REST. I will try to explain all the stuff, but first a few words about TP. So we are located in Zurich. Right today I am Sangalan in the Start Summit. We have a nice pizzeria there, but last time Stefano came, he said I cannot go to the pizzeria because I'm Italian and I cannot trust Italian Italian pizza in a Swiss part. So I believe him, but I will try to get him there next time to have his feedback still. First, before I start speaking about TP, I would invite you, if you're okay, to fill a little poll. So on the last thing that we do is well, because we scan the code to generate build scripts, we have something unreleased yet, but is already in use at some pilot customers. We take source files. So if you have 10 files in a folder, we can split it following the count of function that is inside it, and so in 100 files, for instance. And so we can compile 10 files on 100 cores in parallel and link them afterwards incrementally, or even with standard linking. And then you get way faster builds because we can leverage the actual parallelity of the cloud. And this is coming out soon. And we already provide 8 times build speed up if you just build with the TP cloud, because we do some stuff a bit more optimally than traditional compiler setups and so on.
Doesn't it doesn't it blow up the object file size?
I mean, it's for development purpose. There is, because of the incremental compilation, there is some object file increase, yeah, definitely. But it's mainly for the iterative work that you do. After that, when you're done with that, you can do a normal build, and you don't have the same process of building. Then you don't have this effect. It's more like to iterate fast on what you are doing. It might naturally, if you're in a really performance oriented scenario or any constrained device, you might have an issue. But this can be alleviated if you remove the incremental linking part. Then it's a bit small. It's less fast, but you still have a big speed up of the because of the parallelity following what you change. If you let's say if you change an header that touches all files, you will still be faster, even if you are linking fully all objects again. Yeah. But we are in pilot there, and we'll definitely be happy to have more feedback with new code bases. We are working on pushing that out really soon. And still today, you can build faster with the cloud because we provide Node on demand. You can also build simultaneously for different platforms. But yeah, this talk is not about TP, but still, don't hesitate to register. We will be really happy to have your feedback and talk to you, and see what we can do to make TP way faster. And we'll definitely love to discuss that with you, Pietro. If I'm okay, if I'm right, if that was you who asked the question, we can discuss that afterwards.
Sure.
Cool. So another problem that we noticed by developing TP, so we said, okay, we love C++, and we should do also web app in C++. So my co-founder Yannick said, oh, stay sane, don't do WebAssembly in the browser, and render things in the canvas. So we did some HTML and we do some JavaScript on the browser side, but on the backend we were mostly C++. And then we noticed, okay, our client, or C++ command line client, we have a problem with how do we contact the REST APIs. We thought this was a solved problem, but it seems that actually, even though a lot of code base in C++ do that to our client of web APIs, it's not that easy to do that nowadays. So we said, okay, we should invent everything new, we should invent all the wheels, and that's the reason why I made this presentation. So REST, first, I don't know if everyone knows what REST is here, or if I spend some time about it.
Yeah, I know. I don't know if everyone else.
I know.
Okay.
I've never made something with that. I just have theoretical basis here and there. Just reading, never used, never implemented.
Okay. Yeah, it's actually a software architectural style. It's no standard also, so it can be whatever actually. But it has some basic topics. So it's usually you specify URIs in HTTP with to access resources, and then you do a CRUD request on that using the HTTP verbs to reuse things that are used on the network. And the goal of this was having a good decoupling of client and server to permit a scalability of the web, actually, an anarchic scalability, and a low entry barrier to new developers or to integrate some other services and so on. But this has the effect that you cannot easily machine compute how a REST API is made, and then later there has been a standard that have been added. But namely, it was first called Swagger, and now it's named Open API, and this specification allows to specify how a web service is contacted, and which methods are available, and have some documentation and some requirement on the parameters. And one must see Open API as something like a function specification in C++, like the interface of the web service, but on the web, the HTTP verbs and so on. So I will make a small example with C++ in the coming things. But if I take the pet store typical Open API example, what I will need to actually save a new pet in the pet store is to make a post which will create a new pet on the pet URI. And I will send then some data to this web server, which will be the ID of the pet that I want to have and the name of it. And this will be like in the content of the request. And REST actually implemented in HTTP, because REST can be used in any kind of protocol or of service because it's a style. It's actually mostly look like that, but it can also be XML and stuff like this. But mostly on generally it's JSON nowadays with URIs that represent the different resources that you are working on. And if you have to get all pets, then you /pets. And if you want to update some, you get pet/the ID. Then you can make a put on this entry and update it. Post is to create, put is to update, and get is to get, naturally read them. And that's basically it. So what does it take to write a traditional REST client in C++, actually? Because usually people do write, what I saw in my life, it's that most of the people do write all the REST code themselves because there are no standards. So they tend to write a lot of code to serialize, deserialize also themselves. And so we are looking into that and how we can improve that along the way. I took TP's official cat. So he's named Askel. He's purely functional. And he's really disturbing us because he's always knocking at the window and coming in, coming out at TP. it's really difficult to work with him, but anyway, it's your cat. And we are gonna store him in the pet store, so perhaps you can sell it. It's not true. And let's see how we can deserialize stuff in there. So typically what I've seen for the body of C++ code, of REST requests, is that people write functions like this to JSON and from JSON. Why? Because C++ doesn't have out of the box reflection. So people tend to write code that does that for them. They say, okay, the name field of the person struct goes in the name field of the JSON object, on the address field in the address string, and so on. But this has the big danger that you repeat yourself, and when you repeat yourself, you have a tendency to do some mistakes, perhaps not the first time, but when some colleagues come and modifies the code and so on. And I don't know, but can you spot the bug here?
Should roughly address to the name.
There's a name.
Very good, very good. Sorry, I found it. But this is really hard. I mean, to find that in a code review when you are looking at other stuff and so, you have to be really thorough. So, and this comes because we repeat your stuff actually. So good that you found it. So perhaps we can improve that already since C++03. I've been very active in the Boost Fusion library to allow you also to avoid repeating yourself, because in the past you had to repeat the type and so, but then came auto declare type and so. And actually you can do in C++03 or still today, you can use macros that generate the boilerplate to do the reflection, and then you don't need anymore to write these to and from JSON yourself. So you're still a bit better, but you have to add a macro that specifies the fields that you want to have for the person struct to be serialized. But then you don't need these to and from JSON. We have a library at TP that we built, that we named the library that we built. We named them CPP because we consider that if we need to build a library, it's something that might at some point be in Boost or in the standard. So we try to put them in a namespace that in the future we can better improve and push to Boost or even to the standard. So we made a wrapper around a JSON library, and we made like the opportunity to automatically deserialize and serialize struct. It supports a lot of stuff like optionals and vectors and lists and maps, and it can handle that pretty well. It can also give errors if you got the wrong thing. If you have an optional, it doesn't make an error if it's missing, but if you don't have one, it tells you. So it makes the things a bit more declarative and better, but still you have this old macro thing. So what I propose is we see how the limits are of this topic, because now we have another problem. Is I want to serialize a field that is named, okay, this person or this pet or whatever is public. Do you think I can write this in C++?
I've not understood. You want to write the name public? Public. The string. The name is the string public. This is.
Yeah.
The
name the field is public.
Oh no, this is a problem. You have kind of an attribute that is named public. You can't. It's a keyword.
Yeah, you're right. The problem is that public is a keyword. So at TP we are like this. You know what we do? We do a package manager. So we had to pull GitHub repositories. So we scan the Git repos, and we get the Git reply on what is the keyword that is used in the in the JSON of a Git repo, is whether it's a private repo or if it's a public one. Naturally, it's not. It's called private or public. So we had the problem. Oh, okay. How we deserialize that with our library? We are again back to the to and from JSON thing just because of one field. So we said, okay, it's impossible. Let's move to C++20. We can do that better. So the thing is, in C++20 we have a different new topic. On C++17 we can even do that in C++17 actually with some stuff, with some of the things we can do only with C++17. Given there is different possibilities in C++17, like the structured binding, it's a way that we can use to do some kind of reflection, and then to find the string. If the string is something that is a keyword of C++, we could encode the string as a non-type template parameter, so that we can find it whenever we are iterating on the fields. We can find the string that we need to use in the serialization. And we can also then do that in a way that is actually acceptable for the programmer, because we can do class template argument deduction. So we can automatically create the type that we need from this non-type template parameter with class template argument deduction. The typical argument deduction that you have at runtime, typically for what you have in the between parentheses, you can have them actually for templates nowadays. So there is some implicit conversion that can be done, and this allows us to build our feature. So what is really interesting with structured binding actually in C++ is that it allows to take any type and to access any field separately and give them other names. And actually, someone very smart, who is named Anthony Polukin, made a library that is named boostpfr. And actually what he does is that he relies on sfinai to perform an aggregate initialization to detect how many fields there are inside the user-provided structure. And he used the structure bindings, so he makes sfinai on the structure bindings to decompose a type a type T to a known amount of fields. And if we look at it in the code of boostpfr, so what he tries to do actually with his code is that he has many overloads of the different possible field counts, and because when you have one struct, it has a given field count, it can convert to a tuple automatically, the thing, and then it can detect how many fields the struct has, and he stored that then in a parameter that is hard-coded within the type of the information. Then at compile time, that okay, I was passed a struct with 25 or with 26 fields, and then you can use that to actually iterate over the fields, because you can convert them to a tuple and get on each part of the tuple. And so we at TP, we made it's still not released. It's in the library as a branch. We made an implementation that allows to actually do simply a struct person, and with a small macro, we generate this a field that is of type string, and that can do the serialization of name. But it is something that is actually landing as a key value pair, that takes a string at compile time as a non-type template parameter. So this is this T string. That is, in C+20, you can use std string or have your own CX static string for this. I use the own CX static string because all STL at the moment doesn't have std string ready in C+20. MSVC has, but Clang is not ready there. And what we did is that we take this string, and so you can also specify a name for what is being serialized, because it's a string that we encode in a kind of tag type, is key value pair, and the actual value that is stored inside the field. So if we want to see this in action, I need to open an editor. This perhaps. So as you can see here, we can have the keyword public and have still the public element here, and we can still have automatically serialization that can happen for this tool. for this struct, because we can iterate with boost PFR over the structs. We can look at how it's made in code. I will just build it once. So I didn't build it, I think, for a while. 6.17. So here I'm building locally. TP generates for me the build scripts and so on. It pulls all the libraries that are specified in the depth file here. Like I have a REST client, an HTTP client, sorry, and I have the JSON library. And actually, if I now click on, it's still loading. Normally, if I look at the 2JSON implementation that was installed, we can also look in the sysroot that was installed. We have here pre, where are you? Pre JSON detail, and I think it's in there. We will have a feature for yeah. Actually, what happens is whenever someone gives me a person to my class, I detect it with an SFNI check that actually this struct is not adapted. In the future, we can do that with concept and so on. To have better, as said, it's still a work in progress there. And then I use the Boost PFR library to unpack, let's say, my struct. And then I can just use anything that can iterate over the member of a tuple. Here I use Boost Anna because it's pretty easy and simple. And then for each member of the field, I can call again my class, which knows what to do if it gets a key value pair that we saw before. So if it gets a key value pair, then it will use naturally the key for the name of the field in the JSON. And the value on this goes back to another function that is in my class that generates simply the call to the operator here, which simply creates a name and the value inside the JSON object if it's not already existing and so on. And this is actually there is a JSONizer part and there is a JSONizer part. It's just simply the JSONizer makes a JSON, the JSONizer checks if the script works, but it's all the same thing. And actually, just with this small line of code, we get like for pod types, simple reflection, and so we don't need to repeat ourselves with writing a boost fusion and abstract macro or with adding any reflection information. With that, we can actually iterate over the fields and do whatever we want, and we can get the name of the fields using this trick of using actually non-type template parameters, but as static strings, and using the fact that there is compile time argument deduction, so I can just give a string in the key value pair. And this I do with this small operator here in the macro. The macro gets the name, and if you use the sharp symbol, then it simply actually concatenates strings in macro. So it creates from something that was not a string when it was parsed by the C++ compiler, by the preprocessor, it makes the strings out of it. And then we encode the type, and actually here I simplified the key value pair thing. It can be a type that is totally transparent because here you have a nesting that happens, but this is just like to show how that works and to not have too complicated stuff. It's already really complicated when you start to explain them. And now that we have that, we can actually get to the open API. Actually, I don't know if you are familiar with SOAP, but actually SOAP is a really hard thing. It's hard because it's big auto-generated code from specification of service that are made in XML, and it's really verbose and so on. But it has a nice thing that REST doesn't have in itself, but that REST gets with OpenAPI, is that it has a specification. So you write once the code and you generate the specification out of it, or you write once the specification and then you can generate the server and the client. And then you can agree as a team on the boundary of a service. And the idea is how to get that done in a simple way in C++. And actually getting this niceness from SOAP, that means getting OpenAPI inside C++, inside REST, inside C++. What can we do for this? The thing is, there are some generators, and the problem is the code they generate actually. If I go to the OpenAPI specification of the pet store, .json, for instance, I have this nice small specification that gives me all the path and say, okay, I expect on the pet request, if someone makes a post HTTP request, then it's an operation that is called add pet, create a new pet, and so on. And then typically and traditionally, you would have to implement that all by hand. If you have OpenAPI, you can generate this, but the actual OpenAPI generator, they generate quite some base code, and I can show you what this will generate. So this is the OpenAPI's default C++ generator, generator that generated the default code. And if I look at what was generated for a really simple project, I have many files. I have like API client.h that is generic that I configure, but I have many overload for things that I don't need. It's actually also using a software CPP REST SDK underlying that is actually not that great, and it also generated value types or types that I use over that I can use over the wire with really unsexy getter setters and stuff. And actually, then I need to integrate that in my code. And every time I change something in the spec, it generates a new code with new class names and stuff. And it's a traditional way of doing things. In TP, you can do that. It's automatically endless and so, but it's really, I would say, old school and hard to maintain in the end. So we don't want to do that. We want to do modern C++, and let's skip that part. We're just getting to this. So we want to do modern C++, and why would we need separate tools in our build process? Actually, we could, with metaprogramming, generate the OpenAPI client just with a metaprogram. We don't need to have any kind of generator in between, because actually metaprogramming is coding about the code. So we could scan or different stuff like the person struct we had or the pet struct and generate the client and so. But first, before we do that, perhaps we need to specify the requirements that you want for our stuff. Okay, what we want is to avoid breakage with the remote API of the server. We want a compile error if I type something that wouldn't work against the server, because we know from the spec that I can call the API with some types and with over not, or some URI are not existing. I shouldn't call them. Then I should get an error if it's not respected. And I would like to have auto-completion if I do write that. So that helps me to ensure that if someone changes the OpenAPI spec, I just have to pull it, and then I just try to compile it, and before even doing the first internet request, I know that I'm respecting the spec of the server, actually. So this will be the requirement that I could have to such a tool. And actually, if we combine what we saw before with boostpfr and the field specification with the compile time strings as a non-type template parameter, and we take what Jason Turner presented in 2017, I think, at the CPPCon to parse JSON in a constexpr way, then we can implement all these things. So how does that look like in practice? At the end, we want to be able to do that. copy paste the OpenAPI spec. Here I shorten it for the slide inside the code, and then that will be the first iteration, have a way to say, okay, I want to call the add_pet operation and pass them this parameter. If any of the parameter is wrong, or if the add_pet is wrong, then throw a compile error. So let's see how that works in practice. Here I have the code for this. I'm sorry. So I go through the full example, but perhaps before I get too deep in the craziness of this code, I can show what it looks like when we do that. We vote all this. So we have all this to and from JSON. We need to write a pet like this. But if the pet will be wrong, then I wouldn't know it at compile time. Actually, I have no OpenAPI here, so I cannot know that. So to move to this and to move to a better solution, let me show. I can have the pet struct with this pre-JSON key that we saw before. So here I say, okay, I expect an integer type, string type, and array type. These are the type from OpenAPI. I expect ID, name, and photo URLs for the fields for the pet. And then I can simply say, okay, make me an OpenAPI client from the OpenAPI JSON. So if I look at I clicked on the wrong thing. If I look on the OpenAPI JSON, I'm not. Where is that? Here. It's actually just a string, literals. So here I have all the JSON config with the post, pet, and so on, as we saw before. Inside this JSON, an HTTP file as a string literal. And if I go to the end of the string, I actually just have a special user-defined attributes to actually pass it to my constexpr parser. And if I do here, so I have started TP in monitor mode. So if I do here a mistake in the JSON file, I remove a comma. Then while it compiles, actually, it's actually parsing the JSON and generating the type out of the JSON so that I can access the compile time. And then I get an error telling me that there is an error in the JSON here. If you would run that on MSVC, the error would be way better. It would be like pointing exactly on the point here. This is coming in the next version of Plan. So if I add it again, then the compilation is gonna work. And TP detects that there is a change in the file and just recompiles it for me. And then I get a valid JSON there. So although I cannot make mistake in my config files, it's checked at compile time. Here I could use the TP cloud to be faster, but my connection being not that good right now with the presentation, so I don't want to test that in the live presentation. And so now I've built something, and it built this client. So this client has all the information, and with this client, actually, I can then call operation add_pet. But if I would call add_pet hello, for example, but doesn't exist, then I would also get a compile time error. So it's an operation that doesn't exist on the server. So it's something that is not possible to call. This is tested without me having any code generation happening in the build process. It's just pure C++ parsing JSON and checking these things out. So here I have again the error that this operation could not be found. There is no matching member for call operation. Actually, how works call operation? Actually, call operation is let's go with the search here. Is actually doing a check in the JSON to check if the URI exists, and then performs the call remotely with a typical post request and handling the response. And how that works in the create operation kernel, we just go over the object storage of the path. So we access to the same string, as you see, OpenAPI JSON here, that we had here. It's actually accessed not by character, but by key, because it's thanks to the CX JSON literal. It parsed it as a JSON object, so I can access to the key path that you can see here. There's here the key path. So when I do, I will put it on the side. When I do tipi.build OpenAPI JSON path, I actually get this object here with the pet function and so on. And then what I can do is I can add compile time, because it's a constexpr function. You can see it's even written as consteval to be sure it's executed at compile time, so that we don't get that at runtime, while it will still be possible. And then actually it's a bit dirty, because I hacked this constext JSON parser and so to show that it was possible to do that. We are working on making that prettier. But it's also something Jason Turner just released a new version of his tool. Instead of parsing at constexpr the JSON, it generates a pre-parsed JSON that you can use in constexpr context. So that might be also an interesting thing if you have really long compile times and stuff. But let's keep on what you have now. And then whenever I found the operation ID that matched this one, then I can just gather the information from it, meaning what is expected in the request. For instance, I expect the component schema pet in the post request here. And the component schema pet, if we look at it in the JSON, it's somewhere else it's another key in the JSON that says, okay, I require a name and photo URLs, and the type of ID is integer, and the type of name is string, and so on. So that's the typical OpenAPI spec. And I could just match that in C++. In that, I wrote my pre-JSON keys with an NTP, NTTP, non-type template parameter. Let's go to the part where it is. Here, so I said, okay, I have an ID, which is a name type integer. Here I have name type string, and the array with the photo URLs. And so the code is capable at compile time to check that I give the right name, but it's also capable at compile time to check that what I give are the right set of parameters. So if I were missing name, or I was missing photo URLs, or putting something that is not expected, I would also get a compile error, because it will be checked at constexpr time, actually, at constable time. So let's rebuild that again with the current state. And let's see what we could do to have this better, actually, because this is a bit clumsy to write, let's say. So we would like to be able to write as in the generated code path with the OpenAPI generator and so on. We would like the ability to write a pretty function call add pet, and ask a junior and so on. And to do that, actually, at the moment, because we don't have in C++ meta classes, that is something that would allow generating classes on demand at compile time. I made a poor person meta class implementation that generates code at compile time in a string, but you can then pass in a file. So you can stick to that and you don't have any code generation anymore, or you can also say, okay, I want to print the code here. So let's put it on another line. It's actually, yeah, here. So now it's no more, let's say, it's no more commented out. So what does this thing is, it's Boost MPL is something, or Boost MP11 is something that takes, that can do like compile time processing at with templates. And what we do is actually we apply all operations to to the client that we generated from the constable parsing. And this all operation actually is an MP transform from generate operation T. And what it does, it's simply for each of the operation, we print them out with accessing this NTTP string. And as you can see here, generate operation then gets the data out of the operation and simply generates C code that I can copy paste in my code to have the clean API that I would like to have. So if I run, I already compiled things, but I can also say verbose mode so that we see the output of the test. And here, if I compare with the code, what happens is here we do a first call to the network. We see we are calling with the code the pet store IO, the Swagger pet store IO, and it replies us that it validated the addition. And then we do the same call with this add pet function, but is actually generated from this small line. It just generates this code out that you can copy paste in a convenience header so that it calls the underlying mechanism within NTTP on the compile time strings and so on. And it is allowed to make a cleaner API out of that. So it's still work in progress, this, but I think with the evolving standard and all the stuff that is now coming, when C+20 is really well implemented in all compiler, then we can definitely switch to something really pretty there and have a really nice REST OpenAPI supporting C++ without any tools in between that generates code.